Hola, buenas tardes, ¿cómo están? Bien, Bueno, me da mucho gusto poder presentar y darles la bienvenida. Por primera vez somos hosts aquí en Google para la comunidad Cloud Native de Ciudad de México. Como saben, pues nosotros acabamos de inaugurar el capítulo. Abraham, Arman, Carlos y yo, y Carlos Cano, que no pudo venir. Pero bueno, quiero darles la bienvenida y quiero mencionarles que, bueno, agradecerles por estar aquí, por tener interés de escuchar lo que Lakmal tiene que hablar sobre el proyecto, que es muy interesante. Y también I wanted to thank to Lakmal to share this information with us and to share his time with us. I really appreciate that. Thank you, Lakmal. And I don't know if it's Harsha here, but also we want to thank to Harsha to be the bridge communication between Lakmal and us. So thank you both for this. Y gracias a todos ustedes aquí en Ciudad de México, en las oficinas de Google, por haber venido y esperemos que puedan disfrutar la plática del Lakmal y también que aprovechen el tiempo que nos está dando para hacerles las preguntas que ustedes deseen.
Perfecto. Sí, como menciona Ana, muchas gracias al equipo de OpenChoreo. Es un proyecto Sandbox de la CNCF y tenemos a un maintainer que es Lakmal, entonces espero que aprovechen mucho la sesión el día de hoy con él. Es un VP, es un maintainer del proyecto. Lakmal, thank you for joining with us. Thank you for your time and for presenting with us the interesting session with us about Choreo. Choreo is an open project for the Sandbox that it's basically primarily focused for the platform engineering team. Lakmal will be talking about more details about how they use this in their daily basics. So thank you, Lakmal, and please feel free to start your session with us. Thank you.
Thank you.
Thank you. You guys hear me? You guys can hear me, right?
Yeah.
Yes.
Okay. Let me share my screen. Okay. First of all, I would like to thank Cloud Native Mexico City meetup organizers to having me in your meetup. It is honors to talk to you all. So I will go through some of the slide and then start some live demonstration. I would like to make it a conversational, but I'm not sure how we can make it remotely. But if you want to ask any question, please ask. I can answer. Okay. Little bit of me. I'm Lakmal Warusawithana. I'm one of the OpenChoreo co-maintainer, and also I'm a VP and distinguished engineer as WSO2. And I started my career as a system engineer in 2001. And last 25 years, I was engaging with building many platforms, different kind of platform, different technologies, different era. So now, currently, I'm engaging with creating this OpenChoreo platform. Let me start with the problem that what we are trying to solve. So there are many studies around this area. Like there's few studies showed that 75% of time of the developers' time goes to because of they have to deal with multiple tools. They have to there's a tool sprawl issue. They have to jump into different tool to do different things. And this is where platform engineering movement came up to solve this issue. Like rather jumping into different tools to do different tasks, why not we create a platform and the internal developer portal to improve the developer productivity. The issue in that, not an issue, but in the practice, when you are trying to develop this kind of platform, it will take some time. For example, even if you look at the CNCF Sandbox, CNCF ecosystem, so if you take a single functional area, for example, if you take a observability area, you can find 20 or 30 different tooling, right? So then when you want to build this kind of platform, you need to select one or two tools, and to select this kind of tool, you need to evaluate it. Then you need to study, and you need to build a knowledge around these tools. So it's a very hard problem. So there are 100 of 200 of tools there in CNCF ecosystem. So now to pick and choose a tool, you have to invest some time. Then different tools has a different architecture, and they are evolving with their roadmaps. So even though to integrate with these tools, you have to put a lot of effort. So this is where to build this kind of platform, it will take at least a 2 year to get come to a mature level. But with the current agentic era, now developers are generating code very fastly with the use of the agents. Now, then this generated code, this written application, need to be pushed into the production. Otherwise, they can get the benefit out of it. So then the platform engineering team getting a lot of pressure to cater this frequent releases code into put it into the production. So even though platform, and also if you look at the market, platform engineering skill set are very rare. I mean, it's very demanding, but you can't find many platform engineers. So to build this kind of platform in a given organization is very hard thing to do. So this is where OpenChoreo trying to solve. What if there is an open source platform, complete platform that someone can start to build this platform. So that's where the OpenChoreo project started. So OpenChoreo initially there's a developed by WSO2. So we had a SaaS offering called Choreo. It's like a choreo is coming as a choreography kind of term. So we were offering this kind of platform as a SaaS offering to our customers, and we were running this for almost 4 years now. And all other WSO2 products are open source, but this is only offering we had a SaaS. So we thought of, okay, why not why not can we open source our project itself? Like how the Kubernetes start with internal Google internal use of the Borg system open sourcing, same kind of thing happened. So we couldn't open source as it is our code base. So there's a lot of coupling. But what we have done is we took a approach where we rewrite the entire getting all the concept what we had in Choreo. We rewritten with using Go and make it a Kubernetes native platform. And this year, January, we were donated into the CNCF, and now it's a CNCF Sandbox project. And also we engaged the community, and the late March in this year, we were released the OpenChoreo 1.0 GA release as well. So it's production ready platform now, and you can download it, use it. It's a complete platform. So the OpenChoreo is what we are offering is a complete platform, developer platform, where it's coming with internal developer portal, observability tools, CI/CD tools, GitOps, security, everything as a complete platform. So the idea is platform engineering team can use this platform and configure and create the experience or self-service portal and the platform for their developers to write the application and also maintain their applications in a production runtime. So even though the main persona engaging in this platform are like a platform engineering team and as well as a developer, there are different functionality areas addressing to different personas in organization. For example, SRE team can engage with this platform. I will show some of the capability. So they can monitor, they can troubleshoot, they can create, they can analyze different monitoring tools to get fix some issues. So likewise, there are different level of personas interacting with this platform in their day-to-day operations. And also not only the human, because of the agentic era, so AI agents are in the first class in this platform. So any external AI agent can interact with this platform. Also, we are shipping inbuilt agent as well. So I will go more detail on this aspects. Okay, let me jump into some of the technical details. So OpenChoreo coming with a main two concepts. That's a plane concept and the module concept. So the OpenChoreo has a control plane. That's the main brain of the OpenChoreo, and single control plane can manage multiple other planes. So other planes can be like many data planes, workflow planes, observability planes, and so on. So because of this plane architecture, it's totally, the plane is something totally depending on the isolation requirement, scalability requirement. That's very flexible. Any organization can use these planes to cater their requirement. So because of this plane concept, OpenChoreo can deploy on a across the multiple clusters. So that means it can be deployed in multiple regions. It can be deployed on multiple cloud providers. So because it's the planes can be communicate each other with the control plane, and control plane will orchestrate all the necessary workload across the different planes. Also, a given plane, the capabilities can be installed by using, we have a concept called OpenChoreo module. So, for example, observability plane, you can get logging from either OpenSearch, OpenObserve, or any other modules installing into the OpenChoreo observability plane. So the idea behind this, OpenChoreo is not tied to a single vendor. So it's a community project. So we are not tied to a single vendor for a single capability. So given capability can support by multiple vendors. So any organization can pick and choose what they want to use in this platform, and then the experience will be experience will be built around that tools. So I will more explain how we achieve that our design goal. So at the moment, we have, I think, 18 plus modules in the OpenChoreo module catalog. And now we are targeting to release 1.1 release in somewhere in May. With that release, we are going to extend this OpenChoreo module catalog into the OpenChoreo ecosystem, where not only the modules, community will be build and deploy, build and registers their AI agents and the component types. I will explain what are the component types and like agent skills. It's like a marketplace kind of, it will become like a marketplace. So these things are community build modules and different capabilities. Then anyone can go to this OpenChoreo ecosystem page they can download it, use it in their platform. Yeah, this is the current. Within the current release, we are shipping 2 MCP inbuilt MCP servers, OpenChoreo control plane MCP, as well as OpenChoreo observability MCP. I will demonstrate some of these capabilities. So any external agent can interact with this MCP, and they can do different activities within their day 2 operations. And also, in addition to that, we are shipping inbuilt agents. For example, SRE agent, FinOps agent, architect agent, and targeting different capabilities, assisting to different personas in their day-to-day operation. For example, I will demonstrate how SRE agent assists the SRE personas in organization to troubleshoot issue and reduce the mean time to resolution from hours to like a minute, couple of minutes kind of time frames. Also, with this plane concept, like I said, the deployment topology can be it is very flexible based on your scalability requirement, isolation requirement, multi-cloud strategy requirement. It can be deployed in many Kubernetes clusters. So, and single control plane can manage multiple these environments. Okay, and in addition to the how on this module integration and the control plane and this the architecture, we were introducing 3 main abstraction on top of Kubernetes: platform abstraction, deployment development abstraction, and the architectural abstraction. So let me start with the developer abstraction. So main idea behind developer abstraction, if you look at the average developer, and if we ask the developers to like deploy some application in Kubernetes, it is not an easy task. Basically, it is very complex. If you want to deploy some production grade deployment into Kubernetes, DevOps or platform engineer SRE can do it, but average developer can't do it. And then it will reduce the productivity of developers. So because of that, this is where we our main vision here: hide the infrastructure complexity from the developer. So developers know how to organize a project with multiple components. Component can be a microservices, and single microservice can be exposed some endpoint, and they can also depend on some other endpoints, and also they have the configuration. So these are the developer already know when they do within their development activity in the day-to-day activity. So developer can live within this abstraction what they already knew, and the platform engineer team is main responsible to provide this abstraction for developers. While platform engineer providing this abstraction, they are not going away with the Kubernetes primitives. That's the main idea behind. Platform engineers are very closely working with what they already knew, like Kubernetes primitives. So they can map, okay, we call it component type. When you create a component type, how that component type can be mapped into the Kubernetes primitives. That's that platform engineer's job. So I will explain while doing the demonstration. So platform engineers will use the same primitives in the Kubernetes, and they also come to the SRE kind of operational people. When they're troubleshooting the given issue, they also use the same Kubernetes kind of primitive. But the developer's point of view, they are not seeing this complexity. They will use the high-level abstraction while they are doing the application development. Then we also having this platform abstraction. For example, if you take we have this deployment pipeline, CI workflow, release binding, releases. These are the high-level abstraction we built on top of the Kubernetes primitives. For example, take the development pipeline, deployment pipeline. So because of this abstraction, we were able to soak the underneath tool without breaking the experience. So because developers and the platform is interacting with this high-level abstraction called deployment pipeline, but they don't try to couple to a particular tooling. For example, we can swap plug CD to the Argo CD without breaking the experience because it's abstracted out. So because of this, we were able to build this platform in a vendor and the tool agnostic way. That's the main design principle we adhere while developing this platform. And entire platform is declarative. You can use GitOps because of that. You can configure all these things using declarative way. So you can use GitOps practices to build and configure this platform. Then other abstraction is architecture abstraction. The main the vision and design principle in this abstraction. So if you look at if you're taking enterprises taking a business problem, they first try to break it down into small problems. That they have to use some different design principles. So normally, if you look at the domain-driven design kind of principles, they start with the business problem and they divide it into smaller business problems. So that's they divide it into the domain, no subdomain, and within the domain, there's a bounded context, and within the bounded context, there can be different component. So that's how the people start with designing like an enterprise software. Now, what happened? Even though we use this principle in the design time, when you deploy this into the runtime, this semantic are going to be missed in the runtime. To fix this gap, we introduced this cell-based architecture. We adapted this cell-based architecture. So cell is something mapped to a domain or subdomain in the design time, and the component can be a microservices in time in component in the design time. And when you deploy a domain or subdomain into a runtime, it's deployed into the in technical terms, it will create a Kubernetes namespace and create a microservices within that namespaces. And also cell boundary is something protected by the network policies. So all the component inside in a cell can talk each other, but outside of this cell can't talk a component within a cell. If they want to talk to the component within the cell, they have to come via a well-defined interface. We call it a gateway, API gateways. Then all the traffic coming into the cell is authenticated and authorized traffic only coming to the cell. So it creates a zero trust kind of environment. It protects your business logics within your cell within the cell boundary. And if you want to expose some APIs services, some capabilities to the outside, they have to expose via a well-defined APIs via API gateways. So that's the we have the main design principle is we are trying to preserve the design time concept into the runtime. Because of that, even when your design time, if you create this kind of domain or subdomain, it will preserve within the runtime as a cell and cell boundaries. This I will show a live demo also. So this is the real example. There are I think this is a Google microservice demo. I think so. There are 12 microservices interacting each other, and there are that the gateways can be internal gateways, it can be external gateways based on the requirement. You can expose your different network topologies. Okay, let me quickly jump into the demo itself. Okay, so like I said, there can be different personas can interact with this platform. So I'm logging as a super admin because it is easy to me to demonstrate each persona's capabilities within a single login. So this is a kind of platform engineering kind of view. Yeah, so here this is something like a sitemap. So platform engineer can understand what resources are in this platform. For example, in this given platform, I have a single data plane, and within this data plane can map to a Kubernetes cluster, one or many. And within this data plane, I have created a three environment: the production, staging, and development. And I have wired up all these three environment with the default pipeline, CD pipeline. And there are multiple projects using this pipeline and deploy multiple microservices. I will go more detail. And also there's a workflow pane. So this workflow pane has different workflows, cluster workflows. So it's like a build workflow. And also there's observability pane interacting with workflow pane as well as the data pane to observe and monitor other services. So let me go into one project here. So this is the single project, and this is you can see there are 5 microservices in this project. There are some database services, API services, front end, some back end. That's how this application is developed. And also this is the cell diagram I explained here. This diagram is generating dynamically because of that abstraction. We have the endpoint, dependencies, workload, project, and this abstraction. We can generate this diagram dynamically. The idea behind this, if you walk into a enterprise and large enterprise, so if you ask from anyone, say CIO or any head of engineering, someone responsible, they don't know. Okay, they say, okay, I have 20 say 100 of microservices, but they can't tell how many microservices are utilized in the actual production. So because there's no single place to visualize it. Now what happened with this OpenChoreo? So this is the design time architecture. Because of the abstraction, we can generate it. Now we can draw the same diagram with the runtime traffic and overlay with this this architecture, and we can see, okay, if there are any anomalies, say sometimes even though design time there's a connection to say this service to this service, runtime shows there's no traffic going around that path. That means that connection never used in the production. That means we have some like a technical debt kind of thing. It may be used earlier, but now it's refactor the code, now never using. So these things can be easily identified, and we have to refactor the code if it is not using. And same line, sometimes we have seen there are some lines drawing in the runtime that is not intended to be in design time. That can be a exploit. That can be some threat, because that is not intended to in design time, but someone calling to another microservices in the runtime. So these things can be easily identified using this abstraction and these principles. And also, so like I said, the main problem we are trying to solve is, so developers now tap into the different tools, look into different tools, there are different interfaces, but with this single platform, you can have everything that developer need in their development activities. For example, logs, they can see logs within the platform itself, and also they can see the OpenTelemetry traces. If they want to troubleshoot an issue, they can no need to go another tooling. So, and also if you go say if you go a single component, say if I go this one and say matrices, they can see the CPU, memory utilization, everything within the platform. They can navigate and use it. Okay, so let me quickly show how the developer engage in this kind of platform. So like I said, developers doesn't want to know about the infrastructure complexity. Let me create a, so this is like a developer view. I'm demonstrating as a developer now. So I want to create a component. I can select one of the project. So I'm going to create a component. So when I create a component, this is the component type that platform engineers are created and make available for developer self-service. So there are different component type in here. There's web application, workers, services, scheduled tasks. Let me use services as just a demonstration. So let me create a service. Let me give say my go something like that. So I can give a name. Then I can have choices now. I can build it from the source, or I can give the contain images, or I can use a external CI. Let me show in the building from the source. And this is the CI plane interacting in. So there are inbuilt CI workflows. So I will use the Google build pack. Now I can give them my source as a Git repo. Let me give a simple example. Let me give my source repo. Oops, my keyboard is not functioning. Okay, somehow my keyboard giving some issues. Let me see. Okay, my keyboard having listen. Okay, oh, this is not the place. I want to give it the name, and I give the build from source, build the build pack, Google build pack. I will give the repo here, and I will give the path, repo path, service. So I can, if it is a private repo, I can give the git secret. This is a public repo. I will just go ahead. Yeah, so I create a component. Okay, something happened. Try again. I can go to the branch. This is the main branch. Let me branch here. The service. Okay. Okay, this component is created. Now I can start the build. So developer can within the portal itself, they can trigger a build. And if I go the build, so it will you can go the builds. So it will do. You can have a CI multi-step CI activities here. You can indicate with your code scanning, like a container scanning after build. Anything you can do. We are using Argo workflow here. So it will start a build, and it will when ready, we can deploy. You can go to the CD pipeline, and you can promote into the development and staging and production. So this is a normal developer how engaging with. Let me show. Even now, developer doesn't see anything about the anything about the infrastructure complexity. Now, so this is some already deployed web app. Now, if you go here, so even when you developer just create give a Git repo and make it a web app, underneath it you create the Kubernetes primitives. So here you can see deployment, HTTP routing, services, port will create it. And in addition to that, it will creating a network policy. So by default, it is protected, secured, like I said, with the cell boundaries. All the network policies are applied because it's security is enforcement by the how platform engineer want to do when every deployment into the system. So that's how the governance enforced. So this is how developer will interact with the system. So let me jump into the how we can use this Cloud Code, how we can use Cloud Code to interact with this platform. It can be based on the different persona. Again, I'm looking at super admin. I can do both developer and platform engineering and other personas activity. So I have register. My keyboard died. Let me use this one. I have registered two MCP endpoints, OpenChoreo control plane and the observability plane. So you can see there are multiple tools. There are 90 kind of tools to interact with this MCP. So let me show. Let's say I can interact with the system by giving the any natural language prompts. Say I will just list or something like that. List all component along with their deployed environment. So even though UI you haven't seen that single view, but if you are using this kind of agent with MCPs, it is very powerful. It can create your own view what you want to see because all the tools are integrated into that. You can see it give the summarized version. Here I have two projects, default and URL shortener. And within default, I have multiple microservices, and URL shortener also multiple services. And you can see, for example, say web app, my web. It is deployed in development and also in staging. Let me verify it. So it's in the default project, my web app. It's in the staging, development and staging. Let me give another instruction. Say my web to prod, something like that. So now because of it is connected to the MCPs, so it should be able to create release and release binding and promote this my web into the production itself. So no need to go into the different tooling. It's already promoted. Let's verify it. It's deploying into the production. It should be ready. Yeah. So this is how. So even now, what I have seen is because now developers are more using these agents like Cloud Code, Codex, or something. These agents, and they don't want to move into another tool. They can use the same tool to do their development activity, interact with the platform. So this is very capable and powerful experience we can achieve using this interacting with this indicating with this MCP capabilities. And also I have listed the skills also. So let me say skills. So I have a couple of skills registered. I have a developer skill, insertion skill, and platform engineer skill. Let me use some of the skill and do some complex stuff. So here I have a repo. So I have a repo. I tried different scenarios using the skills and these MCPs. So let me take this scenario. So this is something as I'm a platform engineering organization. So there are two teams are onboarding. Now, for example, in this example, like there are two new teams, payment service team and the custom portal team. And the requirement is payment service team require different environment. They want dev, integration, and production. But the custom portal team, they are saying dev, staging, UAT, and production. So these are real use cases in enterprises. Now, then we need to create environment. We need to create the CD pipelines, and we need to create a project, and we need to wire up all these things. So normally it take, if you're having dealing with multiple tools, it will take like a days kind of thing to set it up. But with these tools, skills, let me give a single prompt. So what I'm saying is I'm onboarding 2 teams, and this is the platform, this is the payment team and the portal team, and this is the requirement. So just giving a single prompt, I will give it in the cloud. Now, so it should be able to create this entire environment less than 1 minute, because it's and it's using very limited tokens because of the skills. It optimize this kind of repetitive activities. So you can see, wait and see. Yeah. So within less than maybe 40 seconds or something like that, 44 seconds, it created the entire provisioning. So let verify it. So if we go here, if I go platform page again, you can see there are multiple CD pipelines created, environment created. Let me verify it again in here. You go to the catalog, you can see, if you go to the environment, you can see there's an integration and staging has created. Let's go to the deployment pipeline. There's a new 2 pipeline created, customer portal and the service payment service. If you go to the projects, new 2 projects are created. If I go inside the project, you can see it fire up with the correct CD pipeline. So not only the developers, with these MCPs and then the skills, platform engineering or SRE can easily work with this agent to interact with this platform, and it is make easier their day-to-day activity. Also, let me show an inbuilt agent scenario. So to demonstrate this one, so what I'm going to do is I'm going to demonstrate how SRE agent can assist the SRE person within this platform. To demonstrate that, so I will use this project. So these are 5 microservices. So if I go, there's a front end. If I go there into CD pipeline, it is deployed in the development. Let me get a URL. This is the front end. So this is a simple like a URL shortener microservices. It uses front end, back end, API, and the Redis and the Postgres to demonstrate the multiple component application. So it's working, right? Now let me create a failure scenario. Let me mimic a failure scenario. Now let me go to the this is front end. Let me go to the API service. Let me mimic a failure scenario. Let me say, so this is the Postgres URL, right? So versus URL. Let me add. Let me misspell. Let me add another S here. So it should. So I just like a human error. So I just add a misspell in my Postgres URL. Now it will deploy into the system. Let's wait a couple of seconds. It's deployed. Now if I refresh this application, it should fail. Yeah, it can't load because it can't get the connect to the database. Now we have this inbuilt agent, SRE agent. This agent will trigger by using a alerting mechanism. So for example, if I go here, if I go the front end, if I go look for the logs, log error, you can see there are some error log because there are 500 error. Let me go to the project again. So now this error will automatically trigger the agent if I go to the incident page, you can see there are already incident created because there are some errors in the logs, and this is an incident created. This can be a triggered for PagerDuty for SRE, and SRE can come into the system. They already know that okay, there's a incident. They can acknowledge it, and so without manually looking at the logs and matrices, all the things, what we have done is, so this SRE agent, there's a sub agent called RCA. That RC agent can generate root cause analysis report automatically. So we are feeding all the matrices, logs, traces, and also config changes, code changes, everything into this agent. Then agent can correlate the context what we are providing and able to generate a report. So you can see within less than a minute, it triggered and also generate a report. We are not stopping there. So let me, for example, this is a report. If I am a SRE, I will get a PagerDuty. I will just come to the system. It's already as RCA report. I can go there. You can see even though the logs appears in the front end, in the highly confident. So what the report is saying, yeah, there's a Postgres DNS resolution error. So that means that Postgres DNS can be either can't resolve it, or it can be some miscommunication. And we are not stopping there. So we have another sub agent called remediation agent, where it can provide a fix as well. So you can see it is saying that, okay, if we apply this fix, it should be fix the issue. Let me apply and see. Okay, it should fix the issue. Let's reload this one. Yeah, basically, it's fix the issue. It's correct the DNS, the correct URL and fix the issue. So it can reduce the mean time to resolution from hours to like a minute kind of thing. So this kind of thing agent can easily do, because we can feed all the context to the agent, and also if the agent is acting proper, behaving correctly, we can make it autonomous as well. We can say, okay, we can give the permission, even though within this agent has a different permissions, they can't do anything. We can control what they can do automatically. So we can give correcting these fixes. If we are confident enough, we can allow that permission, then they can automatically fix the issue without even human interaction. So for example, if I go here, success control, you can see the RC agent like a human. So there's a different set of permission and tools that the RC agent can access. So based on that, agent has their own identity, and based on that, there has some permissions, and we can control the agent behavior, and also we can give more autonomous capabilities to the agent if you are willing to do that. Yeah, I think this is mainly what I want to demonstrate. So basically, the highlight is something. So the main highlights in OpenChoreo, it's a 100% open source project. It's a CNCF governed project, and the problem we are trying to solve is to help platform engineer in team to build this kind of platform, and they can start this platform from the day one itself without waiting a couple of years to build from the scratch. But they have the capabilities, they have the power, the configuration, and how they can want to give the self-service capabilities for their developers. So it's a modular architecture. It's not tied to a single vendor, a single tool. And there's a platform APIs, there's an abstraction and the golden path enforcement, observability inbuilt into the system, and built-in agents help into day-to-day operation in different personas. So likewise, it's coming with the ecosystem around this agentic era. This is what I want to share. If you can try out, if you like this project, give us a star, and we are actively onboarding contributors. So you can if you have a time, you can either create a module, you can create some agent, you can create some skills around this, you can publish it. And also there's all the discussions are open in GitHub discussions. Engage with us. So we are very welcome your engagement in as a open source community development. Thank you very much. If there are any question I can take, I can answer your question.
Thank you. Thank you, Lakmal. If anyone connected online want to ask a question, just raise your hand and unmute yourself, and that will be it. In here, if anyone want to make a question, I can share the microphone to you. No? Yeah. Okay, we have one here.
Hello, this is Edison. I have a question. So do you have like future plans for customers that have like existing applications and they want to migrate to this project in the future?
Yeah, good question. So actually I have written a skill for that. So here you can see this is a sample. So this is a GCP microservice demo. It is I just give this sample. I just gave the repo, and this the prompt I gave. We have this migration skill for that. So it was able to deploy entire 12 microservices within less than 10 minutes. Single prompt, fully automated. Yeah, so you can likewise we are engaging with creating migration skill. So this from the Kubernetes to this platform, but we are creating a Docker Compose to this platform, different VM to this platform. So we are adding different skills. You can integrate that skills. The skill will communicate to our MCPs as well as the taking different other integrations. It will be able to migrate into this platform.
Okay, I see. And another question. So in this case, is it possible to deploy this this platform in one cluster and have the other, I mean, your applications in another one, or is all the applications and services will be hosted in the same cluster?
You can deploy OpenChoreo in multi-cluster deployment. For example, control plane can be one cluster, and the data plane can be another cluster. Data plane where you are deploying your application into that. So it is we are just installing some few agent within this different cluster. That is how we are communicating with this cluster. It can be deployed in a multi-cluster architecture.
Tenemos una pregunta online. Sí, le que se discute.
We have like an online question. If you want to mute, and feel free to ask.
Srihari, you can ask the question.
I don't know if I have missed this, but is there a self-service option, and how is this provisioning the infrastructure for the dependent applications?
What do you mean dependent applications? Like
I mean, for example, front-end needs a Redis, let's say.
Okay. Yeah.
And how's the provisioning happening?
Right. Yeah. So the current what I showed is 1.0. We don't have the capabilities to deploy the resources like a Redis. You can deploy Redis as the component. Like for example, in this sample, it is deployed as a component. It is deployed within your cluster itself. If you go here, so the Redis deploy as a service. So if you go as a service, for example, if you go here, say inside particular thing, get a component, you can service, and you can say something called Redis, like that, and we can choose the correct container image in Redis. It will deploy. So that's the one way what we are supporting at the moment. But with the 1.1 release, we are introducing this first-class concept called resources, where you can provision these resources. For example, if you want to deploy a provision RDS in AWS, it should be able to deploy, create a RDS cluster in AWS and inject all the credentials into your microservice. So we are going to use cross-plane as integration, but it's coming as a first-class concept in OpenChoreo. It's a resource concept. You can manage not only within the Kubernetes cluster, you can manage other cloud service, cloud provider resources within the platform itself. It's a self-service capability.
Cool. Any other question? Any other question?
I have another question. So in this case, you're showing the UI, right? Do we have an option for probably like custom resource definitions to create that? I mean, with the MCP builder or something like that?
Yeah. So basically, everything what in UI you can create as a declarative way. All things are YAMLs. For example, if I don't have a sample here, but if I go here, say the component type, the service, so everything's are in YAML format, and also one way is you can use the GitOps with the YAML declarative way. Other one is you can use APIs. Other one is you can use a UI. Other one is you can use MCPs directly, because we have so for example, in the MCP, you can see there are all tools to create component type, component. So we can ask for the MCP, say, okay, I want to create a component out of this Git repo. It will create all the YAMLs, everything, and then update the OpenChoreo. It will create the component by using MCPs. But source of truth, it's in the control plane. It's in the declarative way. So it's everything as declarative.
Any other question? No? Thank you.
Lakmal, thank you so much for your time and for your experience with this interesting project. We appreciate your time with the community in Mexico City, and we hope that we can connect again in the future with a new talk with us. We appreciate your time.
Thank you all. Thank you for having me in your meetup. Thank you very much.
Perfect. Thank you.
Bye.
Thank you.
Bueno, pues muchas gracias por su tiempo y por la espera. Como conocieron a Lakmal, es un VP y es un maintainer de este proyecto. Es un proyecto de la CNCF. Esperamos que les haya gustado la plática. Vamos a tener igual un pequeño tiempo de networking aquí en las oficinas de Google para que conecten con más Googlers y conozcan a más gente que está aquí en el evento. No sé si les ha quedado alguna duda de la plática, algo que quieran externar. Perfecto. Pues nada, muchas gracias por su tiempo y vamos a estar aquí.
Sí.
Y bueno, como saben, estamos tratando de juntarnos cada mes. Esta es una comunidad abierta, entonces, por favor, siéntanse, los invitamos a que hagan un paper o de algo que quieran platicar. La idea es que si ustedes tienen un proyecto o que quieran compartir con la comunidad, pues adelante. Les estaremos muy contentos de recibirlos y de sentirlo, de estar acá. Hoy, este mes fue en Google, las oficinas de Google, pero siempre vamos tratando de variar la locación. Espero que otra empresa nos reciba pronto y también invitarlos. Y ahí está, entonces, por favor, ahí está el QR. De todos modos, en el recap lo vamos a mandar. Y ahí está un QR por si quieren saber más de qué estamos haciendo en el capítulo aquí en la Ciudad de México. Y pues invitarlos a que participen, ¿vale? Un gustazo haberlos tenido acá. Un gustazo que Google nos haya prestado su oficina para el día de hoy. Y pues, gracias. Y pues allá afuera hay snacks, por favor, y stickers. Así que están invitados a que compartan, conózcanse, y eso es para lo que estamos acá. Un gustazo.
Gracias.